no slipping should occur between the bar and the block. I think means there's a bar, there's a bar, there's a block, and there's a plank. First, I have make notice of that. Slipping will occur. So let's do one thing in the, as I start moving it, this point will accelerate, no? Then at this point starts accelerating. So with respect to plank, what can we apply pseudo force on them? There'll be a pseudo force will act here. Then as no slipping occurs, the pseudo force is trying to pull these two blocks towards right, and the spring force will be in this direction. So finally, what will happen? At maximum elongation, what is the situation will arise is like kxm. So this will be the force that will be acting here, and the friction will act in this direction. So slipping should not occur. What is the maximum permitted value of that? Should be mu m1g it is. No, you forget about the plank. So there's a force acting kxm. What is the maximum force, maximum spring force for which no slipping occurs? If the spring force acting on the block, if it is greater than this, there'll be slipping occurs. Am I right? This is, so what is this kxm? How to relate? How to bring with this acceleration? So at maximum elongation, what is the state of the block? Blocks will be at rest. So therefore, the work done by spring force should be equal to what? Like should be equal to work done by pseudo force. So I'll write it here. No, work done by spring should be equal to work done by pseudo force on the blocks. Work done by spring is how much? Kxm square by 2. Work done by pseudo force. Pseudo force will act on both the things, and it will, so this will become m1 plus m2 a naught into xm. One xm get cancels. So this kxm, I'll substitute this. This is equal to 2 m1 plus m2 a naught is equal to mu m1 plus m2 into g. What is the state of the blocks? So you can ask question like, initially they are at rest. I'll accelerate this plank. The spring force will do work on these planks, and the pseudo force will be doing work, and finally they'll come to rest. At extreme point, what is the state of blocks? Blocks will be at rest. That's why no kinetic energy. I applied actually work energy theorem here. Initially they're at rest. Work done by spring force is equal to work done by pseudo force equal to final kinetic energy. If you are getting difficulties, sir, how do you write all such things? Okay, I think at least we can. Because at extreme point, or at maximum elongation, the kinetic energy should be 0. Initially they're at rest. The idea has started from here actually. Can be asked in advance. Actually, what we do, we'll try to make it things very complicated by assuming something.
How did you write first equations?
There's a maximum force for no slipping between the blocks. There's only external force acting, no? Spring force in the ground frame.
Yes.
This idea is very important. This is again Mercanji theorem. This is, I think, maximum force for no slipping. I'll bring these two blocks separately. What is the maximum value of force for no slipping? For no slipping between blocks, mu m1 plus m2g. I think this is the idea, no? So this is a basic condition what we know. That F max is what? Spring force here. So this is the what is kx and what we should write? What is this? Maximum force applied on the block